Hello, everyone. It is May 2024, and I've invited Richard, Wallis and Teresa from Carbon Cycle to give a overview of solutions, composting solutions for small towns like Tuakau, Pokeno, and I'm hopeful that this will be useful for other towns throughout Aotearoa, but without taking up too much time, I'm going to hand over to Richard and Teresa. Thank you for being here.
Have you shared the screen, Katrine?
No.
Can you share the screen? Oh, you have it shared, don't you? Yes, okay.
The permission is on that you can share it, but I can't see. Okay, looks like it's coming. Right.
Okay.
Hi, Katrina, and thank you very much for this opportunity to have a chat about climate change, biodiversity, and what can be done about it. And first of all, I should say that my background is I was 20 years a lawyer until I started making compost in a school in London, composting the food waste that the school generated and the organic waste and turning it into what turned out surprisingly to be quite a good compost. And it provoked the school to establish a kitchen garden, which ultimately caught the attention of the local MP, who wanted that system of composting, growing food, teaching the children how to harvest the food and turn it into appetizing meals. He wanted that to be in every school in Richmond. So for various reasons that didn't happen in London, but it's been my mission ever since to make that a reality in Auckland and in New Zealand, and hopefully it will spread all the way back to London. So I really want to talk about why that's a desirable thing and put it in the context of global warming, biodiversity loss, and something that we will talk about next, primary productivity. So let's start by imagining Tuakau and Pokeno and the whole of the North Waikato being part of a national network of cities and towns and rural landscapes that are proof against flood. Can you have the first thing? Flood, drought, erosion, wildfire, and loss of biodiversity. And I start with these two pictures of the Amazon because I just want to emphasize that the problem that we have in New Zealand is that we underestimate where we might ultimately end up being. And if you look at the Amazon, that was a highly forested ecosystem that was providing oxygen and clean water and clean air to the world. And if you look at it now as a result of deforestation, you can see that it's in a cycle of flooding and drought. And so you can see the Amazon in flood in the left-hand picture and in drought in the right-hand. And that is what will happen to every landscape. It's already happening to most landscapes in the world. And it's actually happening in New Zealand. And you only need to look at what happened in the Esk Valley during Cyclone Gabrielle to appreciate that. Most people in New Zealand, I don't think, are conscious of what the cause of these events is, beside writing them off as freak events. So I want to imagine a landscape across the North Waikato and across all of New Zealand, where we don't have flooding, we don't have drought, we don't have extreme temperatures, we don't have wildfires, we don't have erosion, we don't have water pollution, and we don't have food insecurity. And and imagine the Waikato River flowing from its source in Lake Taupo to where it discharges in Port Waikato, running crystalline, unpolluted by nitrates and phosphates, and without the scum that seems to inhabit the riverbed, and flowing into Port Waikato, which is an abundant, healthy source of fish and shellfish and marine life. So that's a pretty exhilarating project, I think. So when you look at these flooding, drought, erosion, wildfire events, wherever they happen around the world, whether it be in the Amazon or in Dubai or Central Europe or America or the Western Mediterranean, they're a constant. And every time they happen, you find a commentator, a climate scientist, who is being interviewed about what is the cause of this flooding and drought. And they say, oh, well, it's carbon dioxide emissions. We have to get our carbon dioxide emissions down, and that will cure all these things. Well, other people say that it's not carbon dioxide that's causing that. It's loss of biodiversity, which is part of the sixth mass extinction of life on Earth. And that's difficult to understand by most people. It's the feeling is in most places that biodiversity is something to do with the loss of the polar bear or the loss of the panda or the white rhinoceros or something like that. And most people can't see any connection between the loss of, say, the white rhino or the panther or any of those large mammals. How does that relate to flooding and drought? And so the thing about saying carbon dioxide is the cause of this is that it's easy to understand and it's easy to measure. Wherever you emit a ton of carbon dioxide into the atmosphere, that's a ton of carbon dioxide that affects every part of the globe equally. But if it's an issue of loss of biodiversity, then it's a regional thing. And not just regional, it happens where you live. It happens in your backyard, in your parks, in your rivers. It's highly local. And so we have to start looking at how we can deal with these problems on a local level where we can be effective. So start where you are, with what you have, and start fixing the problem. Because fixing the problem where you are is just as important as everyone else in the world fixing the problem where they are. And so what you find, though, is that the financial institutions, governments, local bodies, local people don't know how to fix loss of biodiversity where they are. And they don't know how to measure it. Well, Johan Rockström from the he set up an institute that came up with this idea that there are 9 planetary boundaries. And can you see the illustration we had there? So they there clearly, if you look at the top left quadrant, distinguish between climate change and biosphere integrity. So biosphere integrity is loss of biodiversity, basically. But what they said is that's not very transparent for the average person. So the best way to look at loss of biodiversity is to say, well, it's a loss of net primary productivity. And net primary productivity is the surplus of carbon dioxide drawn down by photosynthetic vegetation and the respiration of carbon dioxide by feeding animals and fungi and microorganisms. And so if we can just quickly run through that. Oh, that's just the donut economics model that also say loss of biodiversity is outside the livable boundaries of the planet. Next slide. So photosynthesis, I think most people understand it fairly well. The plant takes up water from the ground and carbon dioxide from the atmosphere, and the heat or photons from the sun cause the water to separate into its component parts of oxygen and hydrogen, and the hydrogen hooks up with the carbohydrate, the carbon dioxide, to make sugar, and the oxygen is surplus, so that is exhaled into the atmosphere. The vegetation gets its supply of water and mineral nutrients, which are essential for plant growth and health, from the soil. And that supply is completely dependent on the activities of the soil microbiome. And when you have a complete diversity of microbes in the soil, they mineralize plant available minerals from soil organic matter and from silicate rock, which is present in soils around the world. And so you have the situation that you're dealing with is that ecosystems everywhere are completely dependent on the cycling of carbon dioxide, water, and mineral nutrients through photosynthesizing plants, which feed aerobic animals and microorganisms. And so that feeding results in the respiration of carbon dioxide, water, and it also, the activity of that soil microbiome that mineralizes things, in the process, they produce, in addition to carbon dioxide and mineral nutrients for the plant, they also build incrementally porous soil carbon structure. And it's that porous soil carbon structure that enables the soil microbiome to inhale oxygen and exhale carbon dioxide, and for the water to hold large volumes of water. Or sorry, for the soil to hold large volumes of water. So that's So soil, so if we can get on to the next one. So what you see there is that plant roots deliver exudates, which is the sugar produced by photosynthesis, to the soil microbiome. And you can see, and the soil microbiome is busy respiring and building porous carbon structure. And that activity can go to great depths in the soil. And you can see that on the left-hand side there, where the grasses in that picture have sent roots down, which must be 2 meters or more deep. And so through that entire soil profile, the microbiome is generating soil carbon structure. And the soil has greater capacity to hold water and cycle nutrients. So what Charles Kellogg said, he's not the Kellogg that made the cornflakes, but his brother. And he said that essentially all life depends upon the soil. And there can be no life without soil and no soil without life. They've evolved together. And we can illustrate that with this image here. You can surmise that there's very little actual soil in that picture. And there's no livestock life. And the young shepherd is in danger himself. Now, all life on Earth began with no soil. And we are in the process of reverting to a state where there's no soil left on Earth. And you probably heard people say, oh, well, there's only 40 or 60 years of productivity in the soils. That 40% of the Earth's soils are moderately to severely degraded. And you can see that's a living or dying demonstration of what happens when we lose soil. Now we know that what makes soil is that cycle of water, mineral nutrients, carbon dioxide, pumping right through the whole cycle, through photosynthesis, which creates carbohydrate and oxygen, through respiration, through feeding and respiration, which creates carbon dioxide, water, mineral nutrients, and porous soil carbon structure. So that's and when you have that cycle working properly, you have net primary productivity. So there's more carbon dioxide drawn down into the soil and less respired out. And the difference is the soil carbon structure that enables everything to function. Now, I've put here a quotation. I've put it on the slide so it's there and in the record. I'm not going to read it, but I will read the last couple of sentences. Trees may look like they're moving slowly, but zoom in on their leaves and they are as responsive and dynamic as any animal. Cells in the leaf measure light, humidity, and damage, as well as rates of water loss and photosynthesis. They use this information to decide whether to close their pores to prevent water from escaping or to open them to allow photosynthesis. It's an extraordinary example of coordinated and continuous regulation, as these little valves are just constantly maintaining the plant in a safe place. So what you find is that this whole process of net primary productivity is an example of high biotic intelligence. And what we are doing by farming with synthetic nitrates is bypassing that whole system of nutrient cycling, and the excess of nitrates is burning off the soil carbon. And it's also actually making the soil an inhospitable place for the microbiome on which soil depends, because it creates a highly acidic environment that the microbes don't like. And so that's why across the world, we're experiencing this phenomenon of flooding and drought, because farming with synthetic nitrates has been pervasive across the globe for the past 80 years or so. And it's just slowly worn away the carbon structure. And so we need a global, and that's causing a deficit of primary productivity. So what that means is there's more microbes and animals eating photosynthetically produced organic carbon and putting it into the atmosphere as carbon dioxide, and that's a soil degradation-led process. And so the only way to turn it around is to stop farming with nitrates and to start farming with diverse pasture species and microbial consortia that are the complete package. And by that I mean the way mineralization happens is the diversity of microorganisms in the soil give you two things. They give signaling amongst themselves and between themselves and the plant. And they also each have, there's a lot of redundancy, but in combination, they can produce enzymes that will mineralize out of silicate rock and organic matter a wide range of mineral nutrients. So for good health, animals, plants, soil life requires access to about 50 or more mineral nutrients, mostly in trace amounts. Probably nitrogen is the largest or the most in demand, and that represents maybe 3 or 4% of organic matter. So we're talking tiny amounts, but absolutely crucial for functionality of the whole system. And so, so what we've done by killing off the microorganisms that do the mineralization is nicely explained by Rob Lewis. He says, compared to an ancient forest, a farm, whether for food or trees, is a simpleton. Compared to a farm, bluegrass lawn is a numbskull. What we've called industrial progress would be better called industrial simplification, the stupefying of the earth. And then E.O. Wilson, who's a well-known biologist, he said the biosphere is divided between ecosystems that work for stability and disturbed ecosystems that cannot work. And what we have to recognize is that the way we farm food, the way we grow food, with conventional agriculture and synthetic nitrates and biocides, there are ecosystems that do not and cannot work. So so then this next slide tells us that almost half of the world's habitable land is used for agriculture, animal feed, and livestock, and accounts for 80% of agricultural land use. And that is all farmed with nitrates. So that is all contributing to a net loss of primary productivity. One paper I read recently was written by some, they call themselves carbon accountants, but they worked out that there was a net loss of primary productivity across the globe of 30 billion tons of carbon dioxide, and that's a soil-led loss of carbon from the soil. So what that means is that we're emitting 40 billion tons annually from burning fossil fuels. And there's an additional 30 billion tons going into the atmosphere and not coming back out from loss of soil carbon and loss of biodiversity. So it's a massive problem. And New Zealand is in the prime position to lead the world in identifying exactly what the problem is and what the solution is. And the solution is taking all that farmland. We have about 13 million hectares of farmed land in New Zealand. We can very quickly, through adoption of 6 species of pasture rather than 1 or 2, and that will, and in conjunction with the right consortia of microbiomes or microbiome, that will enable New Zealand to sequester more carbon in the soil, about 3 times more than is needed for us to meet our Paris Convention obligations. So 3 times. So instead of us looking down the barrel of having to spend $3 billion to $24 billion come 2030 for not reaching our targets, we will have other countries paying us twice that amount. So it'll be a net source of revenue. But it's even better than that, because when you farm, when you grow food with the microbiome that generates this porous gas exchanging carbon structure, the water that it holds and the flow of gases generates populations of methanotropes. So they are microorganisms, they're part of the microbial consortia, and they feed on methane. Right, so when a cow bows its head to feed on the grass and it exhales methane, that methane feeds the soil methanotropes. Not only that, if you are in a landscape where you're farming like this, and where your steeper country is forested with native vegetation, which is, unlike pine trees, is very water rich. That moisture creates hydroxyl ions, and hydroxyl ions are unstable compounds that require gases like methane gas to create stability. And so what they're doing is they're converting methane gases. It's a highly powerful free radical, and it converts methane gas into carbon dioxide. So just by...
Are you going to show us some carbon cycle boxes soon?
Yeah, okay. Okay, well, so So anyway, vast ecological benefits that our rural and urban landscapes can easily turn into greenhouse gas absorption and great productivity. And so here we see, this is an urban farm in Auckland. It's on a vacant land site. You could put these things anywhere in any place, you know, plenty of places I saw in Pokeno and Tuakau, we could do this. We gave them 6 carbon cycle boxes, and within 2 or 3 years, they were producing vast quantities of food, all grown without synthetic nitrates, without biocides. The only source of fertility was the compost and the microbiomes in the compost that produced all this massive productivity. They are farming on, this is a community assisted agriculture system, and that farm on 500 square meters is now generating over 120, or about approximately $120,000 of revenue off that 500 square meters. At a per hectare rate, that's $2.4 million. Right, so this is not something that needs support other than the provision of the necessary land and the money to get started, you know, to survive those first 5 years. And then they become a source of jobs and revenue creation and world-leading food systems. And so education is a massive part of the solution. We just need the whole population to understand that you don't need nitrates to produce food, and you can't start early enough. And so this is in an early childhood education centre where we put 2 or 3 boxes. And here's one of the young students, maybe 3 years old, helping us put the box in, checking the levels, and getting fully engaged with the process. And they will be engaged with making the compost and using food waste and green waste to make compost, to create that microbial consortia. It'll be with them for life. This is a photograph of 4 boxes that we have at Sylvia Park. So this is underneath the railway overbridge, and the food court, the food from the food court comes out of the mall just across the road from where these boxes are. It's wheeled across the road in wheelie bins and turned into compost. They've got a water collection that comes off the roadway, off the overbridge, is purified, and we use that water in the compost making, and also to water the garden, which they're using. So they're using the compost from their food waste to grow a garden just a bit further along the road. So it's highly tight circular economy going on there. This is at Tuakau School, where we put a 4-box system in. And we've just put another one in down in Huntley. And what we're hoping to do is to get everywhere where there are communities that can be enabled to make compost with local food waste, local green waste, turn it into fresh food, nutritious food in large quantities that can alleviate the sort of food deserts that a lot of these people live in. And at the same time, educate them about the soil and how to be resilient in biodiversity. And so the last slide is that, so we do the compost boxes, which is a solution at a local level. But here we're putting down 44 cubic meter state-of-the-art composting systems that imitate the conditions that you would find on the forest floor, where these microbial consortia self-assemble. It's aerated through vertical chimneys, and we're using basically wood chip and cow dung. So that will generate highly effective microbial populations that migrate into the soil whenever you use that compost. And so we see that as composting on a larger scale, and it's highly effective when you use it just as a solution. Like you can separate the microbial life out by using a 40 micron sieve, and a gallon or two of that will fertilize a couple of 100 acres. And trials in the United States have shown that treating crops in that way enables the soil to absorb 11 tons of carbon dioxide equivalent per hectare per annum. So it's pretty exciting. And we would love to see that just propagated throughout New Zealand, so that, and through our education system too, so that when people look for a solution to these seemingly knotty and insoluble problems of climate change, that they can look to New Zealand as an example. And then the brand value of that is incalculable.
Excellent. Thank you so much. I am going to stop the recording there, and we'll finish on that screen with your contact details. And I can't wait to see carbon cycle boxes all throughout the Waikato and throughout New Zealand. Thank you, Richard.
My pleasure. Thank you.
That was fantastic. Thank you.